Hi guys, welcome back to part 2 of my Python for Beginners video on data types. So in the last video I went over what each data type was and the basic, in fact just basic information about them. In this one it's going to be quite a bit longer because I have got worked example of the code. But yeah, so let's hop straight into that. If you haven't seen the first part, I suggest you go watch that. Unless you already know what data types are, but you just want to learn how to implement them, then keep watching. And I'll put a card in the top right corner now for you. But without further ado, let's get into the code. As you can see, I'm here in the Python IDLE, so the development environment. And as you can see, I've got some code already typed out so I can show you it. This red code here is all just they're called comments, or well, they're commented out. So a comment in Python, or just in general for programming, is text that you've got within your code file that isn't going to be read by the thing that puts the actual program together. So it has no impact at all on the program other than removing whatever is after or between the um, the comment, however it is that you do the comment in that language. So first thing we got strings. So first up, oh, so what I'm going to do is I'm just going to uncomment these so that we can work with them. The first thing you're going to see is how I define these. So the way we do that is we say what name do we want to give our variable. Okay, so in this case I've done str, which is the standard in Python and most languages for shorthand for string. So I've got string1 and string2, and I'm saying that this name is going to be given using this single equals sign, this value. So in this case, hello, and I'm using the double quotes. So it's quite standard practice to use single quotes for strings, sorry, double quotes for strings, single quotes for single character strings, and then triple quotes if it's going to be like a multi-lined value. Um, You can also just set strings outside of your code, um, and they will act like comments, which is just something to note. Just because having strings just sitting there, it's not assigning to anything. It's not doing any kind of logic. It's just text. Um, so first thing you can do with them is let me uncomment these. Uncomment some of them anyway. So the first thing you can do with them is you can add strings together. Okay, so when I say that, what I mean is you can. In fact, it'll probably be best just to show you. So you can put the text back to back with each other. So in this case, I've got the text hello, I've got the text world. I'm just going to smush them together without any spacing, without anything, just straight up hello world, all in one go. Close that, comment that one out, and go to the next line and uncomment that. So what I've done here is I've put a space between them. Now this isn't the best way of doing it, which is what this one here is. But the main purpose is to show that you can use strings even if they're not assign a variable. Okay, you can just use them wherever you want. So you, rather than actually saying print this, do that. You can actually use them wherever. There's a side note which I forgot to mention right at the beginning is to output anything to your shell or your front end, like your basic front end console, your front end, whatever the user is going to be seeing, use this print function. And that's just, that just outputs to wherever you're going to see the data or the output. So yeah, let's run this. You see, I get hello world with a space. If I was to change where the comment is and use this line instead without this concatenation, as it's called, just that. See, also getting the same thing. Now, this only works because print allows it. Usually, in fact, this doesn't actually add together the values. Okay, I mean, so here they added together but didn't affect each other. Here they're not even added together. This is just a nice thing that the print function allows you to do. It just allows you to sit next to each other. So this is something you should only do when outputting. Comment that and go to my next two lines. So these are the two different ways that you can format using the various actual formatting methods. These are kind of cheaty. These are kind of cheaty methods of doing it because you're not actually formatting it. You're just piecing together your string, which is what I meant when I said you can build your strings. So the old method would be that you would use a percentage sign and then S if it's a string, or I believe you used to use that you use F if it's a float or just a number. Yeah, but what you can do is you do that, and then wherever you want to replace something, you have this. You then follow this once you've closed the string, which you must always do, because otherwise you get something called an EOF error, which is or EOL error, I believe it's actually called, because it's reached the end of the line, or the end of the file in the case of an EOF error, and the string still hasn't been complete. It goes, well, you're telling me that I'm starting a string, which is this one here, but you never actually told me where it ends. But anyway, you then put another one of these percentage signs, and then you have string 1 and 2. So these are the things you're going to be placing inside of here in the order that you're going to be reading them. This is fine. This works. And if you're only putting in, if the data that's in here is all ordered the way you want it to go in, and you're not reusing it, it's perfectly fine. But as you'll see in a later part, or in fact, sometimes you may switch it out. Like you may not like the order. So rather than changing all this text or changing this here, because this can end up being quite long if you want to. You can just change these numbers. Okay, which I'll explain why these numbers are important when I get down to lists, because that is what this really is. It's a list. Well, it's a tuple. But the new method is that you say inside the string, you put curly brackets around numbers. Okay, so what that means is it's saying that between here, pick out the appropriate value inside of this tuple list. Okay, so the lists and tuples, they start their numbering starts at 0. So you've got binary numbers, and the first number in a binary sequence is 0. So yeah, 0, 1, and then this is your 0th item. This is your first item. You run this, they both give you the same thing, but it's just about how you want to show this. This is easier to do more powerful things with, as I might, see, like, say you've got floating values, you can actually say how many decimal places you want to show it. You can also align these values left with a certain buffer, right with a buffer, in the middle with a buffer, all that jazz. There's quite a lot of stuff you can do with it. So that's it with strings. Next up, we've got our numbers. So again, we've got int, so that's short for integer, and float. So int1 equals 3, int2 equals 2, and now, so these are both whole numbers, so these are both integers. These ones, though, are going to be floating values, okay, because this one has something after the integer part. So this is like the units. Because it has a decimal place, it instantly becomes it's called a float. And it's actually uses the float object, but that's going too far into it than this video is about. And then because we're using math logic here, in this case divide, it will also make this a float. So what this is doing is it's actually using two variables that we've already assigned, int1 and int2 to 3 and 2 respectively, and giving us a new value based on that. Now, if I was to change these, this would have a different value at runtime. But if I was to change the value of int1 or int2 afterwards, it wouldn't affect this, because this isn't pointing to this where this is located within like internal memory. It's just looking at the value. Right, so let's go through the different ways you can use it. You can straight up, you can straight up just output these values, just fine. 3 and 2. Okay, there's no issue with that, because what it does is it just automatically goes within the print function, goes show me the string value for this. Now there's internal functions which sort out that just changing it, it implicitly changing its type at runtime, or to get the value. But just as you know, just so that you're aware that you can just output them on their own, just like that. Comment that out and go to the next one. So this is showing that you can add them together and output them at the same time without affecting each other, much like you can with this string concatenation. So if you just output that, and see, you just get the value of 5, but it doesn't actually say, but unlike concatenation, it doesn't just put 3 and 2 next to each other. Now you can do that. You can say the string value of int 1 plus the string value of int 2. You run that just to show, there we go, 3, 2. But what I just did here is called data casting. So that's probably more than the scope of this video, but suffice it to say that with these core data types, you can do something called data casting, which is basically where you say, turn the value that's inside of here, or try to turn the value that's inside of here to this type. So I'm just going to backtrack this code just a little bit. There we go. And then I'm just going to uncomment this again. And now this is where this concatenation and use of these maths operators to do more than just maths, like you do up here, can throw you some issues. So you'd think that this would just say int 1 is int 1 colon, and then it will show the number 3. So here int 2 colon int 2, right, or the number 2. But what you actually get is you get an error. Okay, you get a type error. So basically, you can only concatenate strings. You can't just add, numbers onto the end of strings or lists onto the end of strings. You have to just add string to string, or int to int, or dictionary to or you have to add like to like for them to merge for these base types. So that is where that casting is, where you have to use it if you're formatting your string in this way, which I generally try not to do, because look, this will give me the same output, but it's 4 characters shorter, which isn't a lot, but this doesn't contain a lot of data. Sometimes you're gonna want to list a whole bunch of data, and if you're doing it this way, no, it's going to be so long. So let me just show you that now that does work. Int 1 is equal to 3, int 2 is equal to 2. But this does it in less code, it gives you the same thing. So that's why I use this format quite a lot, because you can just throw in these raw data types without casting them, and it will do that for you, or try to do it for you. So whatever that internal converting to string function does, it will automatically do it, which is another neat thing to do with formatting. So that's it for integers. Like I said, there is more that you can do with them, but that's right, the really basic stuff. But you can also do like your standard maths, like like this value plus this, assign it to a value, which is kind of what we did here, except we did division. You can also multiply, and even amongst this, there's even more stuff you can do with that. Like you can do that, which gets the floored value. So, like say, 3 divided by 2 is equal to 1.5, but this does not equal 1.5. This equals 1. Okay, and that would then store it as an integer, because it's just a full number. So, in fact, no, I think because it is division, it will definitely do it to an integer. If your numbers just so happen to make an integer, because you're using division, you will always get a float. So if you did 4 divided by 2, you won't get 2, you'll get 2.0, which could cause issues down the line. So Next thing I've got is your list, tuples, sets, and dictionaries. So I've got these set. So lists are your basic containers. You just throw data in there. You can, whatever type, whatever the values, whatever the size of them you can want, you can just throw them in there. Do whatever you want with them. So I've created a list of string 1, string 2, int 1, and int 2. Now, if you know, in fact, I will just quickly zoom in my text a little bit. 18. Um, these have got square brackets around them. Okay, so that is how you make sure that what you're creating is a list and it isn't a tuple or a set. I'm going to move sets up here. Okay, because they are quite different in what you can do with them and how you use them. Next up, we've got tuple 1. So that contains the same data, but I've done it as a tuple. Now, the way that you show it's a tuple rather than a list is by putting these curly brackets, these curved parentheses, these curved brackets around it. But other than that, the way you define them is the exact same. And with this set 1, what I've done is I haven't included int 1, int 2, but what I have done is I've added string 1 twice. And this is just so that when I output the value of them, which I'm also going to comment, that you will get only string 1 and string 2, or hello and world. Dictionaries are a little bit harder to create. So what you do is you do the same thing, but when you do it, you use the curly braces or the curly brackets, like you do with sets, but you have to do something slightly different. So you actually have to say what key. You have to use a key. So that is the thing that you're going to be looking at. So whether that, so we say you're looking at this dictionary for string 1, then it will output string 1 there. But yes, so you do that. You put a string there. It's always got to be a string. You can never have anything else there. Otherwise, it will break. If you had number 1 in there, when you're looking up that number 1, it will think you're trying to look at it as if it's a list, which it is not, or which it is not. It's a dictionary. So, it will look for string 1. You then put a colon, and then whatever value you want to associate to that string, or to that key. Note all of these, each item within that container is separated with a comma, um, which is just the way it does it. Um, some programmer names, just like C, they may use like a semicolon to separate stuff. In certain cases, in Python, you use commas. So yeah, I'll just put a couple of them. So I've got string 1, string 2, int 1, and this one here, float 1. But I've actually assigned that the wrong value, and that is so that I can actually say what that I'll show you how to change it. Although I did actually do that at a later point. Well, let's choose. I will change that back to float 1. So let's quickly. The next code just outputs them. So I'll quickly just run this so you can see. As you can see, I've got hello, world, 3 and 2. My tuple is the same. And as you can see, I typed, when I made the set, I said hello, then hello, and world. So string 1, string 1, string 2. But like I said in the when I was doing the PowerPoint presentation, was that the sets only contain unique values. So it's only going to contain hello once. I've then got my dictionary, so it associates string 1 with hello, string 2 with world, int 1 with 3, and float 1 with 1.5. Note that you can put dictionaries inside of lists, lists inside of dictionaries. All of these can be contained within each other. Just as a note, rather than just these really basic single value types. So you can contain nests, you can put containers inside of containers which is called, as far as I'm aware, nesting. So there's that. So I'm going to quickly just hide that again. Now what I'm actually going to do is so this is how you add data to a list. What you do is you use the dot append, okay, which is just a function that you can use on list 1 that is provided by list 1 to allow you to input whatever value you put inside of here into your list. So if I run this now, it will show an updated list 1 that will also contain float 1, which it didn't initially. If I run this now, see it has 1.5 there. Hide that and come down to the next line. So this code here is going to output the same thing, ideally. But as you'll see, we ran into an issue. But the main purpose of this code is just to show you the way that you access the data within the type. So what we do is, like I said, the format string is going to be the exact same because we want to output the same thing. But with lists and tuples, you reference them by their index number. So the order that they went in. Or however, if you've reordered them, then it will be the order that they currently are in. So indexes always start at 0. That's just a fundamental programming thing, unless you're VB. Um, but that's something I don't go into. So what you do is, when you want to access something, you use these square brackets again. Square brackets are used a lot within Python. They're used like more than probably most languages that I know, other than some dumb languages that are purely there to be annoying. There's a whole language that is built up using the different kinds of brackets and symbols and using known ordinary characters. But that's just a funny programming language that someone made for that joke. So use these square brackets to reference an index. So what that means is it's going to look for the 0th item within list 1. The 0th item actually being the first item. Okay, so this is just a program mindset you've got to get into, that 0 inside of a list of any kind, or an array, as they're quite often called, that actually just means the first. And the first index is actually the second item. So say you're looking for, say, the 100th item, then you need to just subtract 1 from that, and that will tell you its index value. So this should just put 0th and then the first. So string 1, string 2. Tuples are accessed the same way as a string, as a list, but so yeah, the only difference in this sense is the fact that you can't change a tuple once you've made it, or you can't change the values inside of the tuple. You can change that variable to contain different values. That's overwriting it rather than adding to it. So next up we've got sets. Now I've done this in the same way that I've done these, but you'll notice that there's, there's something wrong with it that you can't do, other than, the spelling. Um, so yeah, there's something quite wrong with it that you cannot do. So you can't actually do this with them. What you actually have to do is cast them as a list, just to show you it doesn't work. Um, just because you may be tempted to do this because they're just lists that you can't have repeat values in. They are, but they also aren't. And finally, we've got dictionaries. So you reference them again using these square brackets. Inside of here, you put the key. So that is these string values that you put here that reference a value. So we've asked for, we're looking up, we're looking for the key string 1 inside of dict1. So we've got str1, the same here, str2, then dict2, we've got str2, which will just give us the value string 1 and string 2 respectively. So let me run this. As you can see, it prints out hello world twice, which is for the list and the tuple. It runs into an issue. That's because sets aren't subscriptable, which is this thing. This is you this is you subscribing to them. It's called. So you can't do that directly. What you have to do instead, like I said before, is you have to cast them as a list. Okay, so you actually have to change the data type of them to a list before you can do anything with them, or before you can just pull a value from them. So now this should work. Um, I must have. Did I put this in wrong? Right, that is strange. For some reason it did backwards. I don't know why I did that. I didn't change any code. It must just been being annoying. Um, yeah, it might just be being annoying. So yeah, hello world. It prints them all perfectly fine. It's the same thing. They're just the different ways that you use them. Now, if I was to comment this out, this is how you change a dictionary. It's also how you change um, a specific item that's already. It's also just another way you can assign values. No, what you can actually do is you can say this container with this value, so whether that's your index value or your key value, depending on what you're dealing with, is equal to a value. That's another way you can. That's the way you can directly set a value within them, rather than saying, um, you know, list one dot append here, but append this value. You can actually just say list one in this index, which isn't something you want to do. You don't want to add to them in that way. Certainly not lists, because otherwise you can get loads of errors with that. But you can overwrite them that way, and in fact, that's quite often how you do it. Especially if it's a set size list. Um, and then, but in this case, I've changed string 2 to equal YouTube. So rather than saying hello world, it's going to say hello YouTube. So if I run this, you've got the standard for hello worlds. Well, again, it's done that world hello again. Which I'm not sure why it's doing that. It could just potentially be that when it's converting it to a list, it's not caring about the order, um, which is an issue in and of itself. Um, but that's why I tend not to use these in the way that I'm using it here. I generally use that inside of like an interface. to give me a list of things where the order itself doesn't actually matter. It's more about what's contained within it. So that's also another thing to bear in mind, that it isn't ordered in the same way that it went in. So let's close these, comment them back out, and then let's uncomment this. So what I'm doing now is this code is your booleans. So like I said, you can set it as this, use the comparison, or you can just say equals true. And something to bear in mind with Python, um, and this isn't the case with quite a lot of programming languages, but with Python it has to be a capital T and a capital F. If it's a lowercase t or a lowercase f, it will just read it as the name true, the name false, rather than the value true and the value false, which is quite an important thing. So what I've done is I've just set up a formatted string here, just saying that, just showing what comparison I'm going to be doing. If I can just copy this, um, so int one, int two, full two, and this one's checking that this is less than. Okay, so that's just to show the internal logic of what I'm doing to show these values. Okay, so if I run this now, I have an issue, and that's because see, so it's saying 1.5 is equal to 1.5 is true because um, so float 1 was equal to 3 divided by 2, which is 1.5, and float 2 was just set to 1.2 or 1.5 or vice versa. I can't remember which way it was. Yeah, it was the other way around. And then the other one was saying it was false because 3, as we all know, is greater than 2. So it evaluates as false. Right, so that is all I've got time for today, and that's all you really need to know about the what you need to know about the basic data types in Python, and how to use them. So, like I said, that's it for this video. If you like this one, then be sure to hit the thumbs up button. And if you haven't already, it'd be greatly appreciated if you would consider subscribing and hitting the notification bell to stay updated on my latest updates and uploads. But for now, that's me signing off, and I'll see you in the next one.